Good morning, everyone. We're back for our second video on evaluating limits analytically, meaning by hand. And I'm just putting up again the recipe we looked at in the last video, the recipe for limits approaching a real number. Just to review that really quickly, we always start by plugging the x value being approached into the function. After that, if it results in 0 over 0, you have to do something algebraic. Now, yesterday, we mainly worked on factoring. Today, we're going to get into these other two listed ideas here, multiplying by the conjugate and also eliminating the complex fraction. So we'll look at those, and then we reduce, and then we plug the x value being approached back in. So if we pick up where we left off yesterday, we are going to be on example 8 here in this notes packet we were working on. And number 8 reads as follows. The limit as x approaches 23 of the square root of x plus 2 minus 5 all over x minus 23. So step 1 to any limit is to start by plugging it in. So that's what I'm going to do first. So if I put my 23 where the x's are, I'm going to have the square root of 23 plus 2 minus 5 all over 23 minus 23. And this is going to give me 0 over 0. So I'm forced to move on to step 2. Now, you see the square root of x plus 2 minus 5 up top here. This is an example. Typically, when you see a square root within a limit problem, one idea to simplify the problem, to eliminate the 0 over 0, is to multiply the problem by the conjugate of either the numerator or denominator, depending on where the square root lies. So in this case, the square root lies on top. So I'm going to come down underneath here, bringing the limit with me. The limit as x approaches 23. I'm going to recopy the problem as it is. Square root x plus 2 minus 5 all over x minus 23. And I'm going to multiply both the top and the bottom by the conjugate of the numerator. Now, the definition of conjugate is we're going to keep this exactly the same. So we're going to leave the square root of x plus 2, and we're going to leave the 5. But we're going to change this minus sign to a plus. And these two are now conjugates of each other. I'm also going to multiply the bottom by the same thing, so that I'm not changing the value of the problem just the way it looks. Because if you look here, this divided by this is 1. And when you multiply by 1, you're not changing the value. Okay, so then my next step, what I want to do is I want to FOIL the conjugates. So I'm going to throw these two into parentheses, and I'm going to go ahead and FOIL the top. So when I take the square root of x plus 2 times the square root of x plus 2, just change color here, I get x plus 2, just what's underneath the square root. And what's going to happen here is when I take the square root of x plus 2 times 5, I'm going to get positive 5 square root x plus 2. And when I do negative 5 times the square root of x plus 2, I'm going to get negative 5 square root x plus 2. And last but not least, when I take negative 5 times positive 5, I'm going to get minus 25. And then this is all over. I don't do anything with the bottom, and you're going to see why in a minute. I could FOIL the bottom as well, but it's going to get pretty messy. So unless I'm multiplying conjugates, I don't FOIL. So I'm just going to write the bottom as x minus 23 times the square root of x plus 2 plus 5. Now things are going to start to simplify for us. For example, the positive 5 root x plus 2 and the negative 5 root x plus 2 are going to cancel. If I further simplify the numerator, I'm going to get the limit as x approaches 23. If I combine the positive 2 with the negative 25, I'm going to have x minus 23 on the top, and on the bottom, I still have x minus 23 and the square root of x plus 2 plus 5. So you can see why I didn't want to FOIL out the bottom, because now you can see the x minus 23 and the x minus 23 are going to drop out. See, if I would plug the 23 in for x right now, I would still have 0 over 0, and I'm trying to eliminate that, and here it goes. When I cross those out, I'm now left with the limit as x approaches 23 of 1 all over the square root of x plus 2 plus 5. And when I do my final plug-in, put my 23 back in, I'm going to have 1 over the square root of 23 plus 2 plus 5, which is going to give me 1 over 10, 5 plus 5. And that's my final answer. So again, what does this mean? Well, it means that if I were to graph this function and go to the x value of 23, there's no value there. We have a hole in the graph there. There's a discontinuity. But if I kind of get rid of that and just want to see what the y values are approaching as I come into 23, the y values are approaching 1/10. So that hole in my graph is occurring at 23 1/10. And even though I'm not defined right there, that's where my y values are sitting, right around 23. So that's just a review of what we're finding. Okay, let's take a look at number 9. The limit as x approaches 3 of 3 divided by x minus 1 all over x minus 3. Okay, so if I start the limit like I always do, I plug the 3 in. So I'm going to have 3 over 3 minus 1 all over 3 minus 3, which of course you can see there is 0 over 0. Now this is what I like to call a complex fraction. Here I have a fraction, 3 over x, but it sits within a larger fraction, numerator over denominator. So my goal when I have a complex fraction is to eliminate the complex fraction. So what I do is I recopy the problem as it is, 3 over x minus 1 all over x minus 3. And what I do is I find the little fraction within the bigger fraction. So here's my big fraction, right? Here's the little guy within it. And I look at his denominator, x. I'm going to take that denominator and I'm going to multiply each separate term by that denominator. So you see the x there, so I'm going to multiply here by x. I'm going to multiply here by x. I'm going to multiply here by x. And I'm going to multiply here by x. So this is going to result in the limit as x approaches 3. Okay, 3 over x times x is just 3. 1 times x is just x. And here on the bottom, I'm going to have x squared minus 3x if I multiply here. Now, when I plug my 3 back into this guy, I'm still going to have 0 over 0. So I must be able to go further. And now if I look at it, I'm thinking, okay, it's not going to involve a conjugate. There's no square root. Maybe I can factor it. So I'm going to come up here, limit as x approaches 3. Can't do anything with the top, 3 minus x, but the bottom I could factor an x out, and I'd be left with x minus 3. And it looks like these two want to cancel out. The problem is subtraction is not commutative, so I can't just strike these out. But what I can do is think of the numerator. If I sort of flip him around and write 3 minus x as negative x plus 3, then I can actually factor a negative 1 out, which will make the numerator look like this. Take a negative 1 out, and I'll be left with x minus 3. There's my negative x, and there's my positive 3 over x times x minus 3. And once I do all that, these x minus 3's drop. There goes my 0 over 0. And now when I plug my 3 back in for x, I'm left with a final answer of negative 1/3. So that's a quick review of complex fractions. And last but not least here, number 10, it reads the limit as x approaches 3 from the left of the absolute value of x minus 3 all over x minus 3. Okay, now this one's interesting. The first step is to always plug in the value that we're approaching here. I'm not going to plug a 3 in, because if I plugged a 3 in, well, I would certainly get 0 over 0, but that's not what I'm being asked to plug in. I'm being asked to plug in a number just to the left of 3. So that's what I'm going to do. So I'm going to have the absolute value. Maybe I'll plug in 2.9. 2.9 is just to the left of 3, minus 3, all over 2.9 minus 3. And if I subtract 2.9 minus 3, I'm going to get negative 0.1 absolute value over negative 0.1. If I keep going, the absolute value of negative 0.1 is positive 0.1 divided by negative 0.1. And when I take 1/10 divided by negative 1/10, I get 1. So I wanted to show you number 10 just to bring it kind of full circle. Sometimes, even when you're in the midst of a lot of algebra within limits, sometimes it can go back to something as simple as just plugging it in and you get a real number answer. So just be aware every time that you always plug it in first. Okay, thanks for watching.